I'm probably best known for my work on form finding and my research monographs on tension structures. And recently, I've been working on optimal shapes of arch forms. In most cases, with conventional structures, permanent load will be the weight of the structure, because it won't change. If it's a bridge, then it will be the weight of the material in the bridge, while the variable load or transient load will be people walking over it. Well, I have spent a long time thinking what load should be used in form finding, because in the early days of my work I was heavily criticized by engineers saying you must design for the most critical wind load because structure will fail and whatever. And I actually came to the conclusion that no, we optimize the shape for permanent load because it's always there. Transient loads come and go. Now it doesn't mean that we should ignore those loads. We need to check that the structure can withstand these loads. But if it turns out that this optimized structure fails under transient load, then we need to rethink the original structure, rethink the weight of this structure, and of course change the permanent loading and change the shape and check against the transient load again. It's an iterative process, but all design relies on iterative processes. Because conventional design doesn't really start with the question, what should the shape be? We tend to impose the shape. So if we're building something from steel or brick, we know what we want to build, right? We either want to build a spherical dome or a circular arch. We're not asking what the shape should be. Architects may ask these questions, but engineers don't. And then the job of an engineer is to make sure that the structure withstands the loads applied to it. And of course, the most critical load needs to be considered to make sure the structure doesn't fail. But it doesn't mean that this load should be used to optimize the shape of the structure. This question really arises in the areas of earthquakes. And there are those who think that we should build buildings, bridges as heavy as possible so that under earthquake loading, they're not going to fail. Well, a lot of thinking has gone into design philosophy for structures, and it has been accepted, well, at least in Europe, and I believe in the States as well, and Canada and other countries, that we cannot design structures for 100% safety. So what we're designing them for is acceptably low probability of failure. So the probability of failure will always there. So having the choice of a heavy structure falling down or a lightweight structures falling down, I would prefer to have a lightweight structures falling down and causing less damage. And then in any case, this is what nature is guiding us towards. Well, natural structures do fail also. You know, if you've got very, very heavy wind, you know, the trees will fall. So obviously, nature is telling us that, okay, we are optimizing here the natural structures, trees, plants, for statistically prevalent loading. On my very first day at Fray Otto's Institute, he came up to me and said, remember this, the most important thing is to get the shape of the structure right. The rest can be left to engineering calculations.